Okay, so I hope we have some meaningful time. ですね、I have to open the line again. Sorry, I have to open my line. Where is it? The line here. This is different. Opening line. Yeah, it's open. So I have here, and this one I have to. Maybe okay, I think I did it. I'll download it right place. Okay, so it's okay. There's a sample. I don't know. Anyway. So I think okay, so now we consider this one, right? I have the same book. No. See, I try to confirm this relation. Okay, this one. G equal FF transpose. Small g is FF transpose, right? So in order to do this, okay, I made some note. Okay, so first I want to confirm my copy is correct. See my handwriting. I copy text without mistake. That's something I want to check first. Okay. So here is the definition for F. F actually is a tensor. Tensor is like a matrix. So you have like two indices, alpha and I. Alpha go 1 to 3, I go to 1 to 3. So this is 3 by 3 matrix, kind of. Okay, so tensor we sometimes put this double, how to say, double edge arrow. So then I copy this partial alpha xi. This is correct, okay? And small f, this is also a tensor. Tensor is like matrix. So I have this double side directed arrow. Then definition is this gradient of x, vector x. And inside is I alpha, okay? So then this I go 1 to 3, alpha go to 1 to 3, so this is like 3 by 3 matrix. Okay, so I think I copied correctly. So the next thing I want to check is G. Okay, G, definition of G is here, right? So G goes like this. The conclusion is partial alpha x, and x is vector. Okay, should be okay, right? And because x is vector, g alpha is vector. Okay, so then we go to small x, small g. Small g is this, right? Small g is also a vector. Okay, then it partial I x, partial I large x, and large x is vector. Gi is also a vector. So I copied it correctly. Okay, so then we go to next. Next thing is this one probably. We want to go this one, G tensor. this is G tensor. Sorry, maybe I want to change color to make clear. So we want to know G tensor. G tensor is this element of G tensor is alpha beta. And G alpha beta is actually this inner product of G alpha and G beta. Okay, this is the component. I think it's clear. Yeah. And the same thing applies to small g. I don't know if this doesn't say this doesn't say clearly, but we can also say the small here. Same thing apply g tensor, like small g tensor. This is tensor, and g is also tensor. Yeah. So I think it's clear, right? So then I copied it to my note. So I think I copied it here. Sorry, why I don't know how to delete this unnecessary thing. Very strange. Anyway, please tell me if know how to delete this part. Okay, anyway, so G tensor, the element or component of G tensor is G alpha, G beta, vector inner product. Yeah, and small G tensor is element or component is uh, this inner product of this small g. Okay, so I think I copied definition correctly. Then we want to check this relation. G is FF transpose. Yeah, G is FF transpose. Small g is small f transpose. Let me see here. I think I copied it, this and this. So without any mistake, I copied. Now I want to go from G tensor. Yeah, I think so. G tensor, you need G vector, G alpha, G beta. G alpha and G beta is given here as equation 1. So you take a partial derivative with respect to x alpha. Okay, so each component of, I don't know how to use a pen here. I'm sorry, cannot use a pen here, but here this x is vector, so it has a component like 1, 2, 3, x1, x2, x3. Small g is the same thing, small gi, this is vector because large X is vector, and large X has 3 components, 1, 2, 3. So G alpha goes like this. Yeah, you have a vector component is like upstairs. You have x1, x2, x3. Then this index G alpha go to bottom. Okay, partial large X alpha, partial large X alpha, partial large X alpha. Same thing applies to large GB, G beta. Okay, so upstairs you have small x1, small x2, small x3, but downstairs you have, it's too bad. I don't know how to put it back. Very bad. This software is so bad. Okay. Anyway, I don't understand why they changed it. Microsoft. Very strange. See? I don't need this bottom one. I don't know how to do it. Ah, crazy, 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 crazy. Okay, anyway, G beta vector goes like this. So everything you downstairs, every element or every component, you have partial x beta, partial x beta, partial. But downstairs you have partial small x1, small x2, small x3. Okay, so this should be correct. So then you consider, yeah, the component of G tensor, alpha beta component. This is the inner product of these two things, G alpha and G beta. So you just take the inner product. So alpha 1, partial x1, x1. Upstairs you have small x. And downstairs you have large x, and alpha beta. So here second term plus, because this is the inner product. Upstairs you have partial x2, partial x2. And downstairs you have partial x alpha, partial large x beta, right? And the third term is this x3, x3. Downstairs you have x alpha and partial large x beta. And then there is a summation, like 1, 2, 3, if you see upstairs. Downstairs is common. So you keep downstairs a partial x alpha, partial x beta. But upstairs you can make a summation convention. So partial xi, partial xi. This implies a summation, right? So this is the component of G tensor in terms of this definition. Yeah. And now we can calculate what we will get from 526. Yeah, equation 526. That's this. So we need F tensor. F is more like 2 by 3 by 3 matrix. You can see here, F tensor, this goes like alpha I, alpha I, alpha I. So that means alpha is first, I is second, right? Alpha is first, I is second. So this is 1, 1. You go 1, 1, 1, 2, 1, 3. Because alpha goes first, I go second. Yeah, here you can see. Alpha is first, I is second, right? So alpha first, which is downstairs, I go second. So 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3, right? So this is the F tensor. And you can have F transpose. Transpose, you put this one to this part. So this partial x2, partial x1 go here, right? Transpose. Partial x3, partial large x1 goes here, okay? Then partial x1, small x1, partial large x2 goes to here. And this middle one doesn't change position, 2, 2. Then this one partial x3, small x3 and partial large x2 goes here. Partial small x3, large x3, okay? So then like here, right? I think everything is okay. Partial x1 goes here. partial x2, large x2 goes here, partial x3, large x3 goes here. So it should be okay, right? So then you can easily check, for example, the first term. Yeah, you consider this one. See, FF transpose, and that's G. So first, like a 1 component, you can see 1 component. 1 component goes like upstairs. You can see 1 2 2 3 3. Oh my God, this is correct, eh? I don't know. I think I made mistakes when in my calculation. No. Isn't this strange? 1 Oh, it's okay, right? So 1 2 2 3 3. Then downstairs, in this case, 1 because this is 1 component. So let's see, 2 1 component. 2 1, we go to that's this part. Right? This part you multiply this row and this column. So you go 1 2 2 3 3. Okay. Downstairs you see 1 2 1 2 1 2. Oh, I think okay. When I did it by myself, I thought I didn't get this agreement. So I thought something is wrong with that. But now I see this is okay, completely okay. X1. See, if we want to know this part, like 1 3 component of G tensor, you calculate this column and this row. No, sorry. This row and this column. Then you get 1 2 2 3 3, and downstairs you see 1 3 1 3 1 3. So, okay. So this was correct. So equation 526 was correct. Okay, so I stop this video here. So see you next time.